Hello my fellow nerds and welcome to ShadowFlare Remake Devlog Part 2. It's been almost 3 weeks since the first video and I know it's not long, but I somehow managed to make some mentionable progress, and I guess I just like making these, showing you my project. It's like showing you my baby girl's photos. It's truly parents' delight. Okay, this one is going to get divided into 2 segments. In the first segment we're going to sprint through the newly added features, and in the second segment we're finally going to pick under the hood and look at some of my code. Okay, I think that's it. Let's go! Alright, so first and least important, you'll see that I changed the disgusting yellow cube that represented loot from the first video. I switched it to this lovely chest model. These are not the final visual, this is just for now. In the future, every loot will have its own model. If it's a sword, it will be a sword, an armor will be an armor. This is just for me. I also changed the name background color based on the loot category. You'll see that gold is yellow, equipment is blue, and potions are pink. Now let's talk actual features. I finally implemented gold, so if I pick up these lovely creatures, you'll see that, first of all, you'll see that they have different icons. This is not part of the original game. I just thought that 1 coin should look different from 5,000 coins. The total amount updates accordingly, and gold is the only stackable loot in the game. What it means that I can merge these guys, and when they reach their their max capacity, which is 10,000 per grid tile, you'll see what happened when I go over 10,000. It will spit out the spare. Yes, it also works automatically when the inventory panel is closed. If you pick them up, it will do everything as it's supposed to do. Okay, next thing is weight. The weight, you'll see that when I pick up this short sword, you'll see the weight slider went up, the text changed. Weight is only affected by the equipped gear, so carry panels means nothing. Don't ask me, this is how they made it back in 2001. So my short sword weight 10 what? I don't know, but it weights it. And my maximum weight, my maximum carried weight is my strength. In this case it's 100. Now what happens if I go over 100? Let's see. Boom, I'm overweight, everything is red, and sorry, I'm moving slow. My attack is slow. Being overweight is not smart at all. You can see the nerf stats painted in red. These are not part of the original game also. I just thought it's more explicit, and it also works the other way around. So if I pick up this pre-made speed helmet that has 50 attack speed, now my attack... come on. Whoop. My attack speed is now 150, and my animation corresponds to it. Look at me, I'm cat in boots, and let's see this speed shield that has 50 movement speed. Now I'm fast. This is lovely. Okay, next thing is I made a massive architecture namespaces overhaul. This is North Korea in my scripts folder. Neighbors don't know each other. I have like 30 assembly definitions. The communication is strict. Maybe we'll get to it in the code segment. For now, I'll just mention it. Next thing is our skills. This is the new skills bar. It moves based on the open UI panel right here, and when you click on a skill, it changes the active skill. And to use the skill, you need to right-click your mouse, like this one. This is the melee, and let's demo this lovely skill. Let's see if I can catch them both. Shabbat Shalom! Ho, ho, ho. Let's go over what we just saw. We saw the particles, we saw the cast animation, we saw the mana drain. Mana is implemented as well. And we saw another thing, which is skeletons drop loot. The drop loot is very stupid right now. The current system is it drops them at 100% rate. One of these 12 loot drops data. The smart loot generator is scheduled, the actual feature is scheduled far into the future. This is just for now, and I think that's it. Like I said, not much, but mentionable. Now it's time to talk code. Okay, how to start it? Okay. Alright, so my project utilizes the MVC architecture. For those who aren't familiar with it, MVC stands for Model View Controller. The controller is the decision maker, it's the logic, it manipulates the model. Model is sort of the current state. and the model updates the view. The view is what you see. For a more concrete example, you can see this very, very thin basic implementation, and please do not mind the correctness of this UML. This is just for this tiny example. So the enemy model, like we said, it's the current state. It has current HP and max HP. Enemy view has the health slider, and enemy controller as enemy view and enemy model, and the function called take damage. The enemy view sets the health slider based on the current HP. So enemy view implements the Unity callback on trigger enter, gets hit, says, "Oi, I get hit." It does nothing more. The enemy controller listens to his precious view, and says, "I did get hit. Okay, my opponent has 20 damage. I'll reduce 20 HP out of my current HP. Oh, enemy model, I'm sorry. Enemy model current HP is no longer 30, is now 20. Enemy view enemy model shouts, "I changed." Enemy view listens to the enemy model changed and says, "Health slider dot value is now the current HP value, which now is 20. This is a very, very skinny, tiny, basic implementation. Now let's see how this Michigan implemented the MVC in his project, and we will probably go through the entire enemy lifecycle to understand it best. Oh my god, this is going to be a long video. I apologize in advance. I will try to rush it. And okay, focus. Let's go. So square one is the enemy to spawn script. We saw it in the first video. This is a tiny script. It has two serialized fields, the enemy prefab and enemy unit. Prefab is the prefab, like you know and love, and the enemy unit is the stats. It's the scriptable object. It's very, very easily to create 1000 variation of the same enemy with different stats. And yes, okay, and it has also this lovely editor script. Just creates a button. With this button I can set the game object name in the inspector. Like if I changed, let's duplicate this one, let's put it here. You're no longer a skeleton, you're the red skeleton, and I will set your name. Boom, now red skeleton, very convenient for me. You can see here that based on the enemy to spawn position I instantiate the actual enemies. Okay, so who gives two crepes about the enemy to spawn, you might ask? That's a great question, and it's my guy, it's my boy, it's my main man, it's the game manager. If I wasn't married, I would invite him to my wedding. This is my sheriff. It holds all the managers. I will probably add enemies manager in the future. For now, I like it here. Let's see what it does with it. So upon game start, it handle initialization, it init the enemies, and for each enemy to spawn under the enemy to spawn parent, I will create an enemy. Okay, let's see how I will not mumble in your face. It will probably happen if I want it or not. Okay, so this is the spawn point. Based on the enemy spawn point transform, I instantiate the enemy controller. Enemy controller is an abstract class. All of my future enemies will derive from it, so I just instantiate the prefab. I set the spawn point, and I grab the unit stats. These are very important. Forget about scale for now. I create a new unit, a new concrete unit with the unit stats, and then I create a concrete enemy model. I'm sorry for emphasizing so much. This it will be more clear why soon. I create a concrete enemy model with the enemy unit, and then I create a new object called enemy concrete data. The concrete data holds the concrete unit and model, and I shove it in the enemy's dictionary. The enemy's dictionary has the key is the enemy controller, the value is the concrete data. Very convenient. You will see why shortly. So this is the creating an enemy, and then I tell the enemy controller, I'm initializing you. Let's create an enemy. Init enemy function. In its parameters, you'll see that it here I shove the concrete enemy model, but in the enemy controller it gets the base enemy model. Why it gets the base enemy model? Let's see. Base enemy model is an abstract class with almost nothing but getters. The I enemy unit stats, getters. I unit stats are getters. The enemy controller does not decide how much attack it has. It does not decide what's its max HP. It's decided for him from the outside. Oh, you might ask why it has I unit and I unit stats. Well, simple explanation. I unit stats, like the unit stats, the actual unit stats. Never mind. The unit stats are a scriptable object. By definition, scriptable objects in Unity has persistent data, which means they save in runtime. So if I give 6 skeletons the same stats, the same skeleton stats, and I hit one, I reduce 10 HP of his current HP. all of the other 6 will change accordingly. That's why they all have like the base stats. The max HP of all of them is the same, but everyone has a concrete unit, which is not a scriptable object, and I can, you understand, affect everyone individually. So, oh, another thing. If the enemy controller decides to rebel and he wants to create his own model, it can't, because first of all, the base enemy model is an abstract class. It cannot create an instance of it, and the actual enemy model sits in a different namespace. It does not have access to enemies' restricted data thanks to the assembly definitions. It cannot do it. If he even tries to write enemy model in the enemy controller, it will give him a poop emoji. It is not possible. Okay, then it sets the view with the model. This is how the view listens to the model. This code I stole from my previous boss. Thank you, Victor. I will send you this video. You're probably not going to watch it, so thank you, bro. Okay, let's go through the damage example. 7 minutes. Enemy view has the on trigger enter. It shouts, hey, trigger enter, hello. The enemy controller listens to the trigger enter, and then it checks. I can extract this to a single line method. So it checks, is this the player? Is this an attack? I did get hit by the player. Let's grab the attack component out of the object. Attack component has the skill type, we'll see why soon, and the attacker stats also, of course, are unit stats. This is an only getter interfaces. I will not decide how much attack my enemy has. Like in this previous example, we saw take damage and amount. The enemy controller can change the amount. Here, it cannot. Where were we? Okay. I digress. So it grabs the attack, and then it does nothing more. It does not manipulate the data. The data, it says, oi, I got hit. This is the attack. This is the attack information, and this is me. I'm the enemy controller. Hello. The game manager registers to each enemy event. It listens to the enemy cry, and then it grabs the enemy concrete data out of the dictionary we saw earlier, and then it delegates. It says to the combat manager, hey, combat manager, this is the attack, this is the attacker info, this is the receiver info, the enemy who got hit, the enemy stats. Give me the received attack data. So the combat manager is very uncooked. I have to. It does not use most of the stats yet, but it does like check. It has a dictionary with a skill type we saw in the attack script as a key and the actual script data as a value. It can see what is the damage type, if it's physical, if it's magical, what's the added damage. It calculates the entire thing and it shoots back the received attacked data, which is a struct that hold the inflicted damage and is critical hit. The game manager grabs this data. You see? Okay, I thought I wasn't recording. Okay, it grabs this data and then the game manager reduces the concrete unit HP, which is a reference type, so the enemy reference changes accordingly, and it tells the concrete enemy model if it received a critical hit or not. The base enemy model does not know this function. It exists only in the concrete enemy model. And if we're here and the enemy died, I tell the rewards manager, give me the rewards give me the XP reward, struct also based on the stats, and I tell the UI manager, this is the new stats, and I tell the loot manager, handle loot drop. I mumbled a lot for 10 minutes. It may seem a bit cumbersome, a bit overcomplicated, but I promise you, once you get the flow, once you get the hang of it, this is as clear as day. It is so easily debuggable. The communication always has one path, a single path. It's very convenient for me. It always changing. I bet it will change a lot along the way. But for now, this North Korea I talked about, like the accessibility of the script, of the namespaces. I have like 30 assembly definitions just because I have like 3 layers of data. I have like the systems, the loot, UI, enemies, player. I have the restricted data, which are the concrete data types. Like in the first layer I have getters, in the second one I have the concrete types, and in the third layer, or you can reverse it, I have the managers, and no one can talk to the manager. There's not a single script in my game that has an access to the game manager. Thank you very much for watching. I love this. This is my passion. This is my greatest hobby, and I appreciate you for watching. If you're here, thank you very much. Please comment, please curse my code, talk shit about my code. Sorry for my French. And 1 second. I wish you farewell, my nerds, my fellow nerds. Yes. Bye bye. להתראות. Whew.